So I want you to picture a scenario. And fair warning, this is probably going to feel like a little too real for you.
Oh, I think I know where this is going.
Yeah, you're sitting at your desk. Right. It's a Tuesday afternoon. You have this highly specific, crucially important question you need answered for a meeting that starts in exactly 20 minutes.
The classic 20-minute panic.
Exactly. And you know for an absolute fact that the answer exists somewhere in your company's systems. Like, you know someone figured this out last year.
Right, but actually finding it is a completely different story.
Totally. Because to find it, you are staring down this absolute labyrinth. I mean, you've got 3 different shared drives, a graveyard of thousands of poorly named PDFs.
Oh yeah, like Final Draft V3 real final.pdf. We've all seen that one.
Yes, that exact file. Plus, you've got these endless buried email threads and company wikis that literally haven't been updated since, like, 2023. You are completely hopelessly surrounded by information.
You're drowning in it, really.
You are. And yet, sitting there with all that data, you are entirely starved for actual actionable knowledge. You just feel paralyzed.
It is the defining paradox of modern professional life, honestly. I mean, we've never had more data at our fingertips, and yet we have never felt more uninformed when it actually counts.
Yeah.
The friction of finding what we need has almost entirely outpaced the value of having it in the first place.
Right. It's like you feel like an information hoarder who can't find their own car keys. And that universal pain point is exactly what we are tackling today.
It's a massive topic.
It really is. We are taking a deep dive into this fundamental shift happening right now in how we work. A transition from old school information management to what is now being called AI-powered information intelligence.
And this is such a critical distinction to make.
Yeah, and because I know how incredibly noisy this space is right now, we are grounding our entire conversation today in a really comprehensive July 2026 collaborative article from WebDigestPro.
Which is a fantastic resource because it's not just one person's opinion.
Right. It isn't just a single thought leader shouting from a mountaintop. It's this massive synthesis featuring insights from data scientists, machine learning architects, software engineers, and product leaders.
All looking at the exact same phenomenon from entirely different angles, which is vital. Because if we want to set the philosophical tone for this whole discussion right at the top, we really need to clear up a major misconception.
Yeah, absolutely. The fear factor.
Right. When people hear AI-powered information intelligence, the immediate reaction is usually defensive. You know, the fear is that this shift is about AI replacing human knowledge workers.
Which is what you see in the headlines all the time.
Exactly. But if you look at the consensus from these architects and engineers in the source, that's not the reality at all. It's about shifting human effort away from the tedious act of finding information.
Right.
And shifting it toward the much higher value acts of judging and applying that information. The fundamental unit of human work is what's actually changing.
Okay, let's unpack this. Because to understand where we are going and why this shift from finding to judging is so critical, we have to talk about where we are right now. We sort of have to diagnose the disease.
That's a good way to put it.
And reading through these sources, the diagnosis is what they call the great fragmentation. Because our organizations don't actually lack information. If anything, we have too much of it.
Way too much.
Right.
Yeah.
What we suffer from is fragmentation. I was reading this section by Antonio Heredia Morante. He's a data scientist and technical education led, and he uses this phrase that just clicked instantly for me.
The information islands.
Yes, information islands.
It is a perfectly accurate visual metaphor. Because if you look at the architecture of a standard mid to large sized enterprise today, it is essentially an archipelago.
Right, just disconnected land masses.
Yeah, you have human resources data sitting on one island. You have product specifications on another island. You have customer support chat logs on a third. And historically, there have been absolutely no bridges built between them.
And because there are no bridges, the human worker is forced to be the ferry boat. I mean, we are the ones paddling back and forth between these islands all day.
Which is incredibly inefficient.
It is. It means employees end up constantly repeating research that someone else on a different island already did, like 6 months ago.
Yeah.
Or support teams give customers wildly conflicting answers.
Depending on which island's documentation they happen to be reading that day.
Right, exactly. And leaders, people steering the ship, they are forced to make massive strategic decisions based on incredibly incomplete evidence because they literally cannot see the whole map.
And we really have to pause here and ask why traditional information management has failed us so spectacularly. because it's not for lack of trying, or lack of investment.
No, companies have spent billions on enterprise search.
Exactly. But traditional systems were built entirely on three very mechanical pillars: storage, organization, and retrieval. The whole philosophy was you put a file in a folder, give it a tag, and use the search bar to find it later.
Right, like a digital filing cabinet.
Yeah. But the fatal flaw in that architecture is how that search actually works. Because classic full-text search just matches strings of characters. It just matches keywords.
Meaning if I don't type the exact magic word, I get nothing.
Precisely.
Yeah.
It operates on exact or near-exact string matching. So let's say the engineering team calls a product defect a thermal anomaly. Right?
Okay, very technical.
But the customer support team calls it an overheating issue. If you, as a product manager, search the central database for overheating issues, the search engine looks for that exact string of letters.
And it won't find it in the engineering doc.
Exactly. It tells you there are 0 results. The knowledge is there, but because you didn't know the highly specific, localized vocabulary of a completely different department, it remains entirely invisible to you.
That is so frustrating.
It is. It's an opaque system. It doesn't understand meaning. It only understands letters.
I want to pull in a fantastic, concrete example of exactly this from the sources. Ilya Saburov, an AI marketing manager, outlined this beautifully in the context of marketing operations.
Oh, the growth channel example.
Yeah. He talks about how growth channel data in a typical marketing department is just violently scattered. You've got budget spreadsheets in Google Workspace, strategy documents on Notion, lead data in your CRM.
And what's crucial about Saburov's example is that the risk here isn't just a loss of productivity. It's not just about a marketing manager wasting time searching.
Right. It's a hard dollar business risk.
Exactly. The risk is that the team might continue to fund totally unprofitable marketing channels.
Right.
And why? Because they literally cannot see the full picture of their profit per lead.
Right. They know how much they spent over in the budget spreadsheet, and they know how many leads they got in the CRM.
But those islands don't talk.
Yeah, so they don't know the actual quality of those leads. The data screaming at them to stop spending money technically exists, but it's scattered across 4 different islands, so they just keep throwing good money into a void.
It is the ultimate failure of the old paradigm. The system tells you where a document is, but it cannot tell you what it means for your business.
You know, I look at traditional enterprise storage, a massive, overflowing hoarder's garage. Everything you could ever possibly need is technically there.
Somewhere under a pile of boxes.
Right. But when your car is dead in the driveway and it's raining and you desperately need the jumper cables, the fact that they are technically somewhere in the garage is completely useless to you.
The friction of retrieval destroys the utility of the object.
Exactly. But hold on, I have to push back on this narrative for a second. We're acting like this is a newly discovered problem. Has an enterprise search software promised to fix this exact issue for like a decade?
Oh, absolutely. Every few years, there's a new savior.
Right. I feel like every 3 years, a vendor comes in and says, we have unified search, one search bar to rule them all. Why didn't all of those expensive solutions work?
That is a very fair critique, and it gets to the absolute core of the issue. Unified search failed because finding a document is simply not the same thing as finding an answer.
Okay, that makes sense.
The old enterprise content management model treats documents as opaque objects. They're just containers. Dmitry Rusinov, a machine learning architect featured in the piece, explains this with a brilliant metaphor.
Oh, I remember this one, the envelope metaphor.
Right. He says the old way of doing things treats documents like sealed envelopes with a little bit of metadata scribbled on the outside.
Like a return address and a date stamp.
Exactly. Traditional algorithms can only read the outside of the envelope, who created it, when it was modified, maybe a few tags. But AI changes that architecture entirely by opening the envelope and reading what is actually written on the letter inside.
Oh, I like that, reading inside the envelope.
It's a fundamental leap in capability. AI isn't just looking at the title of a PDF. It's using natural language processing to extract entities, legal obligations, complex relationships directly from the unstructured text.
It's actually reading the paragraphs.
Yes, meaning is finally being unlocked. And once you unlock the meaning, you can actually use that knowledge in downstream workflows instead of it just sitting frozen inside a static PDF file on a server somewhere.
Which perfectly sets up the fundamental paradigm shift of the last few years. If we follow Dmitry Rusinov's framework a little deeper, it completely changes how we conceptualize our digital workspace.
He really does.
He lays it out like this. Traditional information management asks where an item is and who has the permission to see it. That's the container mindset. But this new era of information intelligence asks what the content actually means and what should happen next based on that meaning.
That is the content mindset. And what's fascinating here is how the actual day-to-day operational verbs of our work are changing because of this.
Verbs, what do you mean?
Think about the verbs we used under the old model. They were highly clerical. Store, classify, secure, retrieve. It is a very librarian-esque approach to data. You're a custodian.
Okay, yeah.
But under information intelligence, those verbs evolve drastically. Our new verbs become understand, synthesize, infer, and act.
Understand, synthesize, infer, act. That sounds a lot less like a digital filing cabinet and a whole lot more like an actual living colleague.
Precisely. And Antonio Heredia Morante takes this concept even a step further. He argues that we are moving away from systems that merely use data to answer our known questions.
Right.
And we are moving towards systems that help us discover the questions we didn't even know we needed to ask.
Now, that is a wild concept. Discovering questions we didn't know to ask. Wait, let me make sure I'm wrapping my head around this. Because normally the entire premise of a search engine is that I have to know what I'm looking for, right?
Right, exactly.
So if I don't know what I'm looking for, how on earth can I search for it?
Well, let's use an example to ground this. Imagine you are a supply chain manager. In a traditional system, you might search for shipping delays Q3. You know the question you want answered. But in an information intelligence system, the AI has already ingested the global news feeds, your internal supplier contracts, and the weather patterns in the Pacific.
Okay.
You log in and the system just says, I noticed a typhoon is forming near a major port where 40% of our microchips are sourced, and our contracts with those suppliers do not have a force majeure clause covering this specific type of weather event.
Oh, wow. So you didn't ask it about weather at all?
You didn't ask about weather, you didn't ask about contracts. The system inferred the relationship between disparate data points and presented you with a critical business question you hadn't even thought to ask yet.
That is incredible and honestly a little intimidating. But what strikes me is that this shift isn't just some theoretical enterprise architecture concept for, Fortune 500 company.
Now we're seeing it everywhere.
Right, we're seeing this exact behavioral shift in the general public right now. The WebDigestPro article highlights an astonishing statistic. By May of 2026, Google reported its AI mode surpassed 1 billion monthly active users globally.
1 billion. And the volume of those complex queries was doubling every single quarter since it launched.
The search box has quite literally become a conversation window.
It has. The public has been completely trained out of the keyword mindset. Because a traditional document repository only helps if you already know the exact directory structure and the specific jargon to search for.
Right.
But an information intelligence workflow operates entirely differently. It can interpret your messy, natural language intent.
So I could just ask it something really casual.
Yeah, you could say, hey, what's the difference between the severance package policy from last year and the new one they just posted?
And it just figures it out.
Exactly. The system retrieves the approved sources, reads both of them, explains exactly what changed, identifies any potential conflicts with your specific employment contract, drafts an answer, and even flags where a human HR rep needs to step in.
To go back to my earlier analogy, it's the difference between a Dewey Decimal Card catalog and a hyper-intelligent superhuman librarian.
Oh, I love that comparison.
Yeah, because the card catalog just tells you where a book is physically located on the 3rd floor. It's up to you to walk up there, read it, and see if it helps.
Assuming someone didn't misplace it.
Right. But this new AI system is like a librarian who doesn't just hand you a stack of 3 books. They literally read the books right in front of you at lightning speed, compare the central arguments of all 3 authors.
Synthesizing it on the spot.
Exactly. And then they highlight the exact 4 paragraphs across those books that directly relate to your specific, highly nuanced problem and tell you which book has the most updated research.
A very apt analogy. And it really highlights why a specific technical architecture retrieval augmented generation, often referred to as RAG, has become such an overwhelmingly dominant pattern in this space.
RAG, right. We see that term everywhere now.
Yes. RAG is what makes that hyper-intelligent librarian possible. Because instead of just relying on whatever random facts the AI model memorized during its initial training phase 2 years ago.
Which could be completely outdated.
Exactly. Instead of that, RI forces the AI to go to your library, retrieve your specific approved real-world data, and anchor its generated answers directly to that retrieved source material. It grounds the AI in your company's reality.
Okay, so this brings me to a huge point in the source material that honestly threw me for a loop.
Oh, wait, part.
Because if this AI model is the thing doing all this incredible reading, synthesizing, and inferring, it is incredibly tempting to assume that the AI model itself, the neural network, the multi-billion parameter LLM, is the absolute star of the show.
Right, that it's the most valuable piece.
Exactly. It feels like the most important piece of the puzzle, right? The brain.
Yeah.
But reading through the insights from Dimitrios Esfiras and Paul Nadezhkin, they present a really surprising counter-narrative.
They do.
Oh.
And frankly, this might be the single most counterintuitive, paradigm-breaking takeaway from the entire deep dive.
I'm glad I'm not the only one who thought so.
No, it's wild. Both Sfiras, who is a software architect, and Nadezhkin, an executive, explicitly argue that the AI model itself is actually the easiest part of the entire equation.
Wait, hold on. We're talking about frontier models that cost hundreds of millions of dollars in computing power to train, built by the smartest machine learning PhDs on the planet.
Yeah.
And you're telling me that the brain of the operation is the easy part. How is fixing a local company's messy SharePoint drive harder than training a generative AI?
What's fascinating here is the difference between scientific achievement and business application. Like, yes, creating the model is a monumental scientific achievement.
Unquestionably.
But from the perspective of an enterprise trying to use it, the model is entirely commoditized. Anyone, from a teenager in their basement to a Fortune 50 CEO, can buy access to a frontier AI model via an API for fractions of a cent per word.
So you don't have to build the engine, you just rent it.
Exactly. Therefore, the model itself offers zero competitive advantage to your business because your competitors can rent the exact same model. The real, defensible, incredibly difficult value lies in the operational layer built around that model.
The infrastructure, the scaffolding.
Exactly.
Yeah.
Because you cannot just take a brilliantly smart large language model and plug its API directly into a messy, disorganized, decade-old corporate shared drive.
Let me guess it doesn't end well.
If you do that, you don't get intelligence, you get chaos at the speed of light.
Oh boy.
Yeah. Waqar-ul-Wahhab, a full-stack and DevOps engineer quoted in our sources, spends a lot of time talking about the absolute non-negotiable necessity of what he calls a clean pipeline.
A clean pipeline. What does that entail exactly?
Well, before the AI ever even gets to look at the data, that content must be systematically ingested, normalized into a consistent format, aggressively deduplicated, validated for accuracy, and enriched with metadata.
So, to use a very domestic analogy, you have to completely clean your house, pick up all the laundry, and organize the furniture before you let the robot vacuum loose.
That is perfectly stated, yeah.
Because if you don't, the robot vacuum is just going to suck up your shoelaces, knock over your plants, and smear dirt everywhere.
Precisely. If you feed the AI garbage, unstructured, duplicated data, it is going to beautifully and confidently extract entities and relationships from garbage.
It's going to give you a very articulate summary of your own mess.
Yes. And beyond just the cleanliness of the data, there is the massive existential issue of security and permissions. Paul Nadezhkin issues a very stark warning about this in the text.
Right, I remember seeing that.
He emphasizes that sensitive fields like employee salaries, unreleased earnings reports, personal health information must be explicitly hidden or excluded before the retrieval step happens.
Okay, let's play this out. What happens if they aren't?
It's a disaster.
Let's say a company gets lazy, or they just want to move fast, so they ignore the complex permissions layer and just connect the AI assistant to everything in the company's cloud architecture. Doesn't the AI just filter the answer before it shows it to the user?
That is the exact trap many companies fall into, and it is technically disastrous. If user permissions are only checked after the AI generates an answer, it is already way too late.
Why? If it doesn't show the user, isn't it safe?
Let's say a junior marketing associate asks the AI a seemingly innocent question about departmental budgets.
Oh.
If the AI has unrestricted access, it might retrieve the CEO's private emails regarding an upcoming round of layoffs to help formulate its response.
Oh, no.
Right, now the system might have a last-minute filter that says, wait, this user isn't authorized to see the CEO's emails, I shouldn't output this. But the knowledge of those layoffs has already leaked into the model's context window.
It's already in its brain for that session.
Exactly. It has already used that forbidden information to shape its reasoning. So it might output a highly evasive answer or inadvertently summarize the mood of the emails, basically kipping off the user.
Wow.
In that scenario, your helpful, expensive AI assistant has suddenly become a massive, automated engine for internal corporate data leaks.
That is terrifying.
Access has to be controlled per user and per specific use case right from the very start of the pipeline.
So if I'm a CEO and I decide to just write a massive seven-figure check to buy the smartest, most expensive AI model on the market, it won't magically fix my company's bad data habit.
Not at all. In fact, it will aggressively magnify them. Ilya Saburov has a brilliant, highly quotable line on this exact dynamic. He says AI applied to poor data does not create intelligence. It scales disorder.
It scales disorder.
Yeah.
That is a chilling phrase.
It really is.
You're not buying intelligence, you're just automating and accelerating your own internal confusion.
Exactly. This is why the sources spend so much time emphasizing advanced architectural designs. They talk about hybrid retrieval systems.
Okay, what is a hybrid retrieval system?
This is where you don't just rely on the AI's semantic understanding. You mix traditional keyword search for when someone really does just need to find a specific string of numbers with semantic, meaning-based search.
Oh, so you get the best of both worlds.
Yes. And then you layer on strict metadata filters and user-level permissions. And then Dmitry Rusinov points to something even more advanced, a structural evolution called graph RAG.
Graph RAG. Okay, I saw this in the text, and honestly, it went a bit over my head. Break that down for me mechanically. How does that differ from what we have been talking about?
Sure. To understand graph RAG, you first have to understand standard vector search, which is how most basic AI retrieval works today. Vector search takes words and concepts and turns them into mathematical coordinates in a massive multi-dimensional space.
Math coordinates, got it.
Right. Words that have similar meanings are grouped closer together in that space. So it searches for meaning by looking for mathematical proximity. It looks for words that are similar.
Right, so if I search for dog, it also finds puppy and canine because they are mathematically close to each other.
Exactly. But here's the limitation. Sometimes the most crucial meaning in a business doesn't sit in how similar words are. It sits in complex, rigid relationships.
Can you give an example?
Let's say you have a specific internal company policy regarding data retention. And let's say there's an external government regulation, maybe GDPR in Europe, that mandates a completely different retention schedule.
Okay, so a conflict.
Right. The words in those two documents might not be mathematically similar at all. They're written in totally different legal styles. Vector search might completely miss the connection.
Because they don't share vocabulary.
Precisely. Graph RAG solves this by building an explicit knowledge graph. Think of a detective's corkboard with photographs and red string connecting them.
Oh, I love that visual.
Graph RAG creates nodes, which are entities, documents, or concepts, and explicit edges, which are the relationships between them. So the AI understands, unequivocally, that policy A is legally subservient to regulation B, even if they don't share vocabulary.
It maps the complex structural web of dependencies in your business.
It forces the AI to understand the rules.
That is incredibly powerful because it stops the AI from just guessing based on vibes, right?
Right.
It forces it to understand the actual structural rules of the company. And it's a big, but it also sounds like a massive, grueling engineering undertaking.
It is not trivial at all.
Right, you have to build the graph, clean the data, set up the permissions. So let's say a company actually does this. They survive the gauntlet and build this complex, clean architecture. How does it actually change the daily lives of the people using it?
Because we are clearly moving far beyond just having a chat window open on a second monitor. That is the crucial pivot. The standalone destination chatbot, where you leave your work, go to a separate window, ask a question, and copy-paste the answer back. That model is rapidly becoming obsolete for real enterprise work.
Nobody wants to toggle between 10 apps.
Right. The real shift is embedding AI seamlessly inside the workflows people are already using every day.
So it's just there in the background.
Exactly.
Yeah.
We're talking about AI agents autonomously routing complex support tickets to the right department based on reading the customer's emotional tone and the technical nature of the issue.
Instead of a human having to read every single one?
Yeah. We're talking about AI automatically extracting key financial entities and obligations from 50-page vendor contracts the moment they're uploaded, or instantly drafting initial email responses to vendor queries for human review.
That saves hours of work.
Paul Nadezhkin uses a really evocative metaphor for this. He says AI in the workflow is an exoskeleton for a strong team.
I love that exoskeleton visual because if you put an exoskeleton on a strong worker, they can lift a car, it amplifies their capacity.
Absolutely.
But, to stretch the metaphor a bit, An exoskeleton doesn't give you balance. If you don't know how to walk and you put on an exoskeleton and stumble, it's going to amplify the stumble, and you're going to crash through a brick wall.
It multiplies capacity, but it doesn't create fundamental expertise where none exists. That is the exact risk.
And if we look at the reality of adoption, the statistics in our sources are quite sobering.
The exuberance is definitely meeting reality.
Yeah, Gartner predicted that 40% of all enterprise applications would have task-specific AI agents embedded in them by 2026.
But in the exact same breath, they warned that over 40% of those agentic AI projects will be canceled by 2027.
Wait, almost half of them canceled within a year? Why?
Because of massive runaway cloud compute costs and entirely unclear business value.
The ROI just isn't there.
Exactly. And this is backed up by other data. The sources cite 2025 reports from MIT and McKinsey showing that only a tiny fraction of companies, somewhere between 5 and 21%, are actually capturing massive workflow redesigning value out of generative AI.
So what separates the 5% who are transforming their business from the 40% who are canceling their projects and just eating the loss?
The sources argue forcefully that the difference comes entirely down to what they call workflow-first adoption.
Workflow first. What does that look like?
The failures happen when a company's leadership just buys a suite of expensive AI tools, gives everyone a license, and says, here, use this to be more productive. It's a technology in search of a problem.
Yeah, just throwing tools at people.
The successes, however, happen when a company completely ignores the shiny AI for a moment and instead identifies a specific, highly broken, highly expensive, highly tedious human workflow and uses AI as a surgical tool to fix that specific bottleneck.
I want to ground this again. I remember Ilya Sabirov had a great metric on this. He described a highly specific marketing workflow where an embedded AI assistant was tasked with consolidating over 100 different weekly marketing reports from across various regions and platforms.
Oh, that's a great example.
Yeah, the AI instantly normalized all the disparate data on customer acquisition costs and profit per lead into one unified dashboard. By having that instant unified view, the team was able to immediately identify and cut more than 20 unprofitable marketing channels that same week.
See, that isn't vague productivity.
Yeah,
That is immediate, measurable, bottom-line business impact.
exactly. And Dmytro Rusinov provided an equally compelling example from the logistics and supply chain industry.
Right, I remember this one. The document routing.
Tell me about the routing.
He described a logistics platform that was basically drowning in paperwork. They were processing roughly 300,000 pages of highly complex, varied customs and shipping documents every single day.
300,000 pages, and humans were reading all of them.
Humans were reading all of them. So they implemented a system with confidence-based routing. The AI was embedded into the ingestion workflow. It would read the document, extract the data, and assign a confidence score to its own extraction.
Okay, so it grades its own homework.
Basically, if the score was above, say, 95%, it processed it automatically. No human touched it. But if the document was weird smudged handwriting, a bizarre foreign format, missing fields, and the AI's confidence score dropped, it instantly routed that specific document to a human expert.
So they didn't replace the humans at all.
No, but they cut the human review load by about 80%. The humans only looked at the hard stuff.
So what does this all mean? When I look at those two examples, it sounds to me like bad AI adoption is like taking a standard commuter bicycle and strapping a massive multi-million-dollar jet engine to the back of it.
That sounds dangerous.
Right. Sure, it looks incredibly cool. It's definitely using cutting-edge advanced technology, and your CEO gets to brag about it on earnings calls. But it is fundamentally dangerous. The frame of the bike is going to rattle apart, and it doesn't actually help you commute to work any better.
It just makes the crash happen faster.
Exactly. If you want to use a jet engine, you cannot just strap it to the old way of doing things. You have to fundamentally redesign the entire vehicle from scratch. You have to redesign the workflow around the new propulsion system.
That is the perfect way to contextualize it. If you apply high-speed AI automation to a broken, inefficient process, you don't get innovation. You just get much worse results delivered much faster.
But wait, if we are embedding this technology into everything, if it's automatically reading logistics forms and consolidating financial reports at lightning speed, what happens when the jet engine misfires?
The hallucination problem.
Yeah. What happens when the AI just makes things up? Because if my exoskeleton walks me off a cliff, I'm still the one falling. The danger of these high-speed automated workflows is that a hallucination isn't just a funny quirk anymore. It's a terrible decision made at an unprecedented automated scale.
This is exactly why the conversation in the developer community has aggressively shifted toward traceability. Waqar-ul-Wahhab makes a vital point here.
What does he say?
He notes that the real danger of a generated AI answer isn't just that it might be wrong. The danger is that it feels so dangerously authoritative.
Because it speaks so well.
Right. Large language models are designed to please the user. They output perfect, fluent, highly confident prose. Because of that psychological trick, the system cannot just give you an answer. It must carry its mathematical and documentary sources with it.
It's Ronald Reagan's old Cold War proverb, right? Trust but verify. Except the AI makes the trust part incredibly easy because it sounds so smart, and the verify part incredibly hard because it generates so much text so fast. The sources bring up a deeply alarming study from Stanford back in 2024 that really hammered this home for me.
Legal research one?
Yes. They tested several leading AI tools that were specifically designed and marketed for legal research, and they found that these highly specialized models hallucinated, meaning they completely fabricated case law rulings or legal precedents between 17% and 33% of the time.
Which is staggering.
In legal research, an industry where verifiable facts are literally the only currency that matters.
And that Stanford study is exactly why Dmitry Rusinov issues a crucial, nuanced warning that every single person using AI for work needs to internalize.
Which is?
That grounded is not the same as correct.
Okay, stop right there. I need you to explain that distinction for me, mechanically.
Sure.
Because I thought the whole point of Origi Retrieval Augmented Generation was to ground the AI in my company's data so it wouldn't hallucinate. If it's grounded, shouldn't it be correct?
That is the logical assumption, but it is dangerously flawed. Let's trace the mechanics of a request.
Okay.
You ask a question. The AI goes into your company's database, retrieves a real internal company document, reads it, and generates an answer with a neat little footnote pointing to that exact document.
Right. Sounds perfect.
The AI has done its job perfectly. It is not hallucinated. It is entirely grounded in your provided data. But what if that document the AI retrieved was an early, outdated draft of a policy from 3 years ago that someone forgot to delete?
Oh, wow. Okay, I see where this is going.
Or what if it retrieved the final current policy document, but there's an unwritten, highly complex departmental exception that every human in the office knows about, but which was never officially codified into the text?
So the AI doesn't know about it.
Right. The AI's answer is perfectly cited, it is perfectly grounded, it didn't hallucinate a single word. And yet the answer it gives you is completely practically wrong.
Yeah.
It is a lie delivered with a flawless footnote.
Think about the psychological impact of that for a second.
It's huge.
Imagine trusting a GPS navigation system that confidently instructs you to drive your car directly into a lake. And as the water is rising up your windshield, you yell at the GPS and it responds, "But I am perfectly grounded. I am navigating based on this beautifully rendered, highly detailed, officially approved map from 1995.
Exactly.
If an AI gives me a footnote, my human instinct is to drop my guard. My brain says, it cites its sources, it must be true. How on earth do we fight that built-in psychological bias?
The experts in our sources argue that we have to fundamentally change the user interface of AI. AI systems must be designed to explicitly show uncertainty.
Show uncertainty.
Yes. We have been trained by decades of computing to want our software to give us binary, definitive, confident answers. But Dmitry Rusinov points out something profound.
Yeah.
He says the actual practical value of an AI system in production depends significantly less on how often it's perfectly right and much more on whether it possesses the architectural self-awareness to know when it might be wrong.
That is a total paradigm shift in how we evaluate software. We don't want the software to sound like a know-it-all.
Right.
We want the software to say, I am 80% confident it's this based on this one document I found, but the document hasn't been updated in 4 years, so you really, really need to double-check my work here.
Exactly. The architecture must include an evidence layer that runs parallel to the generation layer. This evidence layer performs freshness checks to ensure the retrieved document is current.
That makes total sense.
It runs contradiction checks, mapping the knowledge graph to see if another internal document says the exact opposite thing. And most importantly, it establishes confidence thresholds to escalate the query to a human when the available evidence is thin or contradictory.
To see exactly how high the stakes get when an AI might be wrong and why this evidence layer is so critical, we have to look at the industries where errors don't just cost a company some money or embarrassment.
But where errors cost lives.
Exactly. The WebDigestPro article highlights healthcare and pharma as the ultimate, unforgiving proving grounds for AI intelligence.
They absolutely are. Medical information and healthcare operations are the ultimate stress tests for these systems.
Because there's zero margin for error.
Zero. Our sources provide two deeply detailed case studies here that illuminate how to do this correctly: CureAxis and Nexentria. Let's look at the mechanics of CureAxis first.
Okay.
It is a healthcare SaaS platform focused on clinical documentation. And what is vital to understand here is how and where they integrate the AI.
Right, because setting the scene here, the current workflow in most clinics is miserable.
Oh, doctors hate it.
A doctor spends half their time trying to make eye contact and listen to the patient, and the other half of their time turned away, typing furiously into a cumbersome electronic health record system. The documentation is a massive point of friction. It causes physician burnout.
Exactly. So CureAxis addresses this by bringing the AI directly into the room.
How does that work?
The medical speech-to-text transcription and the subsequent generation of the SOAP notes, the structured clinical documentation, happens inside the clinical encounter workflow in real time as the doctor and patient speak.
Oh, so it's basically listening and taking notes.
Yes, but because this is healthcare, the architecture is intensely rigorous. It requires strict cloud tenant isolation. Patient data from Hospital A can never, ever cross-pollinate with a model's understanding of patient data from Hospital B.
And the human accountability piece is non-negotiable.
Precisely. The AI listens to the conversation, extracts the medical entities, cross-references the patient's isolated history, and drafts the clinical note. But the AI cannot finalize anything.
It's just a draft.
The clinical judgment, the legal liability, and the final patient-facing output stay entirely and exclusively with the qualified human doctor. The doctor must review and sign off on the AI's draft.
And then the sources detail Nexentria, which operates in a slightly different but equally critical space: pharmaceutical medical information.
Right, pharmacide.
Let's say a doctor or a patient calls a massive pharmaceutical company with a highly complex edge case question about a drug's potential side effects or off-label interactions. Nexentria's AI helps instantly classify the intent of that telephony inquiry.
It figures out why they're calling.
Exactly. And it retrieves the exact medically approved documents from the pharma company's vast database and drafts a scientifically accurate response.
But again, with strict guardrails.
Right. The workflow enforces that the final answers rely entirely on approved evidence and mandatory human review before anything is communicated back to the caller.
Because the mathematical reality of the risks is simply too high to allow full autonomy. The sources cite a highly relevant 2025 study published in NPJ Digital Medicine.
Oh, this one is sobering.
The researchers looked specifically at LLM-generated clinical notes and found a 1.47% hallucination rate.
Here's where it gets really interesting, because context is everything with statistics.
Absolutely.
If you tell a high school student they got a 98.5% on a final exam, they are absolutely ecstatic. A 1.47% error rate sounds mathematically amazing in isolation.
It sounds like an A+ read.
Right. But if that 1.47% represents an AI-generated error in your personal medical chart, a hallucinated allergy, a fabricated dosage amount for a critical medication.
It is absolutely terrifying.
Terrifying. And the study noted that 44% of those hallucinations were rated by physicians as major.
This is exactly why global regulatory bodies are aggressively stepping in to mandate the architecture of these workflows.
Yeah, they have to.
The European Union's AI Act, the European Medicines Agency, the FDA in the US, and the European Commission's Draft Annex 22. They're all converging on very similar frameworks. They explicitly require human oversight and severely restrict the use of probabilistic generative AI models in critical regulated applications.
Waqar ul-Wahhab summarizes the ethos of this perfectly in the text, I thought.
He really does.
He emphasizes that AI can draft, it can triage, it can organize, and it can summarize, but a human must remain legally and morally accountable for anything that is published or acted upon. As he puts it, a confident wrong answer is worse than no answer.
A confident wrong answer is worse than no answer. Honestly, I feel like that should be plastered in neon letters on the wall of every single tech company right now.
It really should be. Because an obvious hallucination, an AI making up a drug interaction that clearly doesn't exist, is easy to catch if a doctor is paying attention.
Key phrase.
Yeah.
They're paying attention.
Right. But there is a much quieter, sneakier, vastly more insidious risk that we need to talk about. A risk that happens precisely when humans stop paying attention.
Ah, yes, the hidden risks.
The sources dedicate a fascinating section to this. The hidden risks of automation bias and semantic normalization.
This section of the analysis is truly eye-opening because it deals with psychology as much as technology. We are dealing with the dual compounding threats of human laziness and algorithmic smoothing.
Smoothing. Okay, let's start with the human element. Automation bias. Paul Nadeshkin warns about what he specifically terms the formal signature risk.
The formal signature, meaning you are required to sign off on a document, but you just sign it blindly without actually reading it. You rubber stamp it.
Precisely. It is a well-documented psychological phenomenon.
Right, like blindly clicking agree on terms and conditions.
Exactly. When an AI tool is usually right, let's say it has a 98% accuracy rate over your first month of using it, your human brain naturally adapts to conserve energy. You begin to trust the machine implicitly.
You let your guard down.
You start approving its outputs on autopilot. The mandatory human review process, which looks great on a compliance flowchart, becomes purely symbolic in practice. We lose our critical edge entirely because the machine is good enough most of the time.
Which is absolutely terrifying when you remember that 1.47% major error rate in those clinical notes.
Right.
If the doctor is on autopilot, exhausted at the end of a 14-hour shift, and just clicking approve, approve, approve on the AI's drafts, that fabricated dosage error slips right through the net.
But the other hidden risk mentioned here is even more philosophical, and frankly, I had never even considered it until I read this article.
The semantic normalization.
Yes. Alexei Chesnikov, an independent writer and researcher featured in the piece, introduces this concept. I need you to break down the mechanics of this for me. What exactly is the AI doing?
Well, to understand semantic normalization, you have to understand how large language models actually write. They don't think in ideas.
Right, they just predict the next word.
Exactly. They predict the next most mathematically probable word in a sequence based on vast amounts of average human text. And because they aim for the highest probability, they have a profound inherent bias toward the average.
Toward the middle ground.
Yes. They naturally tend to smooth out sharp edges. When an AI is asked to summarize a complex, highly nuanced, or perhaps deeply controversial document, it almost inevitably produces a safer, more neutral, homogenized version of the original argument.
So it waters it down.
It completely flattens the author's original distinct voice. It removes narrative tension.
Yeah.
And most dangerously, in sensitive analysis, it can completely erase legitimate dissent, hesitation, or uncertainty.
Wow. Let me try to visualize this. It's like taking a deeply passionate, groundbreaking, slightly radical research paper written by a brilliant, eccentric scientist who is raising massive red flags about a project.
Okay, good setup.
And handing that paper over to a hyper-cautious corporate PR department to summarize.
Oh, that's exactly what it's like.
The PR team rewrites it into a bland, inoffensive, corporatized memo. The memo might be technically, factually accurate on the surface, the dates and the names are right, but all the soul, all the vital nuance, and all the crucial red flags the scientist was trying to raise have been completely ironed out in the name of readability.
That is exactly the mechanism at play. Semantic normalization improves readability at the direct expense of critical analysis. It replaces friction with fluency.
That is such a huge trap.
It is,
Yeah.
and this is why Alexei Chesnikov argues that human reviewers have to fundamentally change how they evaluate AI outputs. When you review an AI summary, you cannot just check for factual accuracy. Checking the numbers isn't enough.
You have to check for tone.
You have to actively ensure that the meaning, the underlying uncertainty, and most importantly, the dissent from the original source materials have actually survived the algorithmic summarization process.
You have to make sure the AI hasn't just yes-manned your complex data into something pleasant but strategically useless.
Exactly.
Fighting these risks, both the human automation bias and the machine's semantic normalization, requires not just incredibly vigilant users, but a completely new breed of builders. Builders who deeply understand the immense psychological and structural gravity of what they are creating.
And that brings us to a fascinating shift in the industry landscape.
Yes, the sources delve into the builders' small teams and the global developer ecosystem, because AI is fundamentally changing not just how software works, but who can actually build it.
It is radically lowering the barrier to entry for software creation. because AI can now write functional code. Small teams or even solo developers can now architect and build incredibly powerful, highly complex workflow tools.
Stuff that would have required a massive, heavily funded engineering department just a few short years ago.
Right. But as the sources rightfully point out, while the technical barrier to writing syntax is much lower, the organizational and ethical responsibilities remain absolutely massive.
Right, because a three-person team can build an AI tool over a weekend, but they still have to deal with enterprise-grade security, international data privacy laws, and compliance standards. They can't just wing that.
No, they definitely can't. Paul Nadezhkin offers a really practical golden rule for this new era of lean development, the build versus buy rule.
Build versus buy.
He argues that developers should buy the platform, but build the logic and data specific to their business.
It makes perfect economic and structural sense.
Yeah. If you're a small team, do not try to build a foundational vector database, a complex LLM orchestration layer, or a zero-trust security protocol from scratch. The risks are just way too high.
So you buy those from established vendors.
Right. Pay for the infrastructure. But
Yeah.
use your small, agile team to build the highly specific workflow logic, the proprietary data integrations, and the deep domain-specific guardrails that actually make your company unique.
The sources highlight some amazing, very human examples of global collaboration happening in this space. They spotlight the Chingu V61 project, where developers like Thnessis Kufos collaborated to build an AI-powered application called DashFetch.
And they built it entirely across multiple international time zones.
Which is wild.
Hmm.
And the takeaway there wasn't just about the cool code that they wrote. It was proving that shared operating rhythms like asynchronous agile methodologies and mutual human trust are arguably just as important as the actual AI models they were using.
The human element is still paramount.
Definitely. And there are massive community events popping up, like Bugbar's Humanity 2026 conference in Delhi, which was organized by Kumbhai Shukla. The entire focus of that event is shifting the developer mindset away from the old Silicon Valley mantra of moving fast and breaking things toward a new ethos of building with judgment.
This is where the open source ecosystem is playing a truly vital, evolving role. Joaquin Lort and Ignacio de Loyola Diaz Jimenez argue in the text that open source communities are no longer just repositories where developers go to get free code to speed up their projects.
What are they then?
They have evolved into a massive, collective peer review layer for the entire AI industry. It is about demanding transparency, applying shared scrutiny to new tools, and fostering rigorous human debate.
Sort of crowdsourcing the guardrails.
Exactly. The open source community provides the necessary friction to prevent rapid AI-assisted development from completely outrunning security, ethics, and accountability.
But I have to play devil's advocate here for a second. Let's be real.
Sure, go for it.
If an AI can write 80% of the code for me and I no longer need to be a senior battle-tested software engineer to launch an app into the world, doesn't that inherently mean we are just going to be absolutely flooded with a million terrible, unmaintained, highly insecure AI wrappers and apps?
Yes. That is a very real, very present risk, and honestly, it's already happening to some degree across app stores and enterprise marketplaces.
I mean, I see them everywhere.
Right. Which is exactly why small teams and independent builders inherit the absolute hardest parts of software development in this new era. As Alexei Tesnikov notes, the easier it is to physically type the code to build a tool, the more important judgment becomes.
The builder is no longer just a typist of syntax.
Precisely. They have to decide architecture. They have to decide what specific processes should be automated, what processes absolutely require mandatory human checks, and what data is simply too sensitive for the AI model to ever touch.
So the responsibility doesn't magically disappear.
No, it just shifts from the mechanics of writing code to the philosophy of designing guardrails.
That is a brilliant way to frame it. And honestly, this evolution of the developer perfectly mirrors the evolution of every single professional, no matter what industry they are in.
It really does.
If the AI is going to handle the raw information processing, the basic coding, the summarizing of meetings, the extraction of data from PDFs, what is actually left for the human worker to do?
That is the existential question.
It is. And it leads us perfectly into the final insights from our sources, future skills, and the continuing scarcity of judgment.
And the remarkably good news here, the optimistic takeaway from all these technical experts, is that professional human skill is not disappearing.
It's not becoming obsolete.
No, it is just shifting. Antonio Redi Morante points out that the historical days of being highly valued simply for memorizing vast amounts of information or being able to recall obscure facts are definitively over.
A machine can do that infinitely better than you.
Much better. The new, incredibly scarce, highly compensated skill is the ability to ask better, more incisive questions, to frame complex, ambiguous problems correctly, and to critically evaluate the evidence the AI presents to you.
AI literacy and what the sources call technical empathy become paramount. I really love Heredia Morante's peer-to-peer learning model that he outlines.
Oh, the rotating roles.
Yeah. He suggests that professionals need to constantly rotate through different roles. One day you are the builder of the AI prompt or workflow. The next day you are the critical reviewer of someone else's AI output.
And the next day, you are the facilitator.
Right, the facilitator mediating the friction between the AI's logic and the human team's reality. You learn how to critique effectively and collaborate deeply. The sources even mention a fascinating side effect of all this.
What's that?
How asynchronous conflict resolution on distributed global teams actually forces much clearer human communication. Because you don't have the informal, nonverbal cues of being in the exact same physical room, you have to be incredibly precise, explicit, and unemotional in your writing to resolve a complex technical issue.
That ability to communicate complex, nuanced reality clearly is a fiercely future-proof skill.
Yes, it is.
If we connect all of this to the bigger picture, it fundamentally changes how we view and value expertise in the job market. Deep, hard-won domain expertise actually grows significantly more valuable in an AI-driven world, not less.
Really, more valuable.
Absolutely. Because as AI gets better at sounding confident, the human expert becomes the only person in the room who possesses the lived experience and the nuanced intuition to look at a perfectly formatted, confident, highly plausible-sounding AI summary and say, wait a minute.
The math looks right, but that's just wrong.
Yes, the real world doesn't work that way.
It makes me think of the relationship between an airline pilot and the plane's autopilot system.
That's a perfect analogy.
The autopilot is technically flying the commercial plane 90% of the time, right? It keeps the plane perfectly level at 35,000 feet, making micro-adjustments faster than a human ever could.
Yeah, but airlines do not pay pilots hundreds of thousands of dollars a year to just sit there and watch the autopilot work.
Exactly. They pay them for their deep experiential expertise during the chaotic moments of takeoff, during a crosswind landing, and for that exact, terrifying edge case moment when an engine sputters in the middle of a massive thunderstorm.
The AI autopilot handles the routine, predictable volume. The human pilot handles the edge cases, the complex judgment calls, and carries the ultimate moral and legal accountability for the lives on board.
That is a perfect encapsulation. Ilya Saburov sums this entire dynamic up perfectly in the sources. He states it plainly. AI is the assistant. Humans own the judgment, the accountability, and the final decisions.
It really couldn't be said any better.
What an incredible, dense, and fascinating journey this has been through this material. We've gone from drowning in the anxiety of isolated information islands and fragmented, messy data to understanding the highly intricate, rigorous architecture needed to build a clean pipeline and a knowledge graph.
We've covered a lot of ground.
We really have. We've explored the very real dangers of automation bias and hallucinated facts, and arrived at the realization that the ultimate safeguard against failure in this new era isn't just writing a bigger check to buy a smarter AI model.
No, it's not.
The ultimate safeguard is cultivating sharper, more critical, more engaged human judgment.
The overarching lesson from all these architects and data scientists is clear. Information intelligence is not about automating the human out of the loop.
Right.
It is about equipping the human to make better, faster, more accountable decisions based on a foundation of traceable, reliable evidence.
Absolutely. And as we wrap up this deep dive, I want to leave you, the listener, with a final lingering thought. Something to chew on that builds on everything we've discussed today.
I'm all yours.
We talked earlier about the concept of semantic normalization, the AI's natural mathematical tendency to smooth out sharp edges, to make complex things agreeable, and to inherently erase dissent and friction in its summaries.
Right, the smoothing effect.
If that smoothing effect is the default behavior of our powerful new AI tools, then in the fully AI-powered future, a company's greatest competitive advantage will absolutely not be its raw computing power or how many autonomous agents it has running in the background.
It will be the preservation of human friction.
That is a profound takeaway. The most wildly successful organizations in the next decade might actually be the ones that actively cultivate disagreement.
The ones that lean into the messiness.
Exactly. The ones that relentlessly encourage debate and that fiercely protect the eccentric, dissenting, difficult voices in the room, because they will recognize that human friction, that messy, uncomfortable clash of distinct, non-normalized ideas, is the one vital spark of true innovation that the algorithm is mathematically designed to eliminate.
It's the one thing you can't fake.
It is something to think deeply about the next time you are sitting at your desk, overwhelmed by a mountain of data, and you are tempted to just blindly click approve on an AI-generated summary to make it all go away. Thanks for taking this deep dive with us.